And over to you, Kathy.
All right, thank you, Stacy. So thank you all again for taking the time to spend time with us this morning. I want to welcome you to our third virtual event. The first event that we had was a virtual town hall with local students. The second virtual event we had was on the connection between soil health and water quality, and that was with Dr. Kathleen Treseder, who is a soil scientist and an ecologist, and that was a really fun discussion. So if you missed it, we recorded it, and so I encourage you to find the link on my Facebook page or pull out an old email that I sent from the campaign, and there's a link in one of the last emails that I sent, and you can watch it on YouTube. So I encourage you to do that because that was a really fun discussion as well. And so today we're talking about water quality. And so first I want to introduce myself to those of you who are meeting me for the first time. I'm really excited to see some new names on this Zoom call. So thank you again for joining us. So I am Kathye Armitage, and I am a candidate for a seat on the board of directors of the Santa Clarita Valley Water Agency, Division 3. And normally, as a candidate, I would be having in-person events and I'd be out knocking on doors, trying to introduce myself face-to-face, but I want to be respectful of the need for distance right now. So that's why we're using our technology instead to connect us all virtually for events like this. And I'm also spending a lot of time on the phone having great conversations with voters safely that way as well. So again, for those of you who don't know me yet, I'm going to take you just a few minutes to tell you a little bit about myself and why I'm running. So I've been a resident of Santa Clarita for the last 17 years, and initially the first part of my career path was in public health. And so I'm really proud of the work that I did at the LA County Department of Public Health to improve the health and well-being of the underserved populations in LA County. And then I pivoted into the field of sustainable natural resources and studied how we can work towards sustainability. And it was during that time where I became really interested in the complex issues of water management in California. We have a fantastic water systems technology program here at our local community college, College of the Canyons. And so I've taken advantage of that as well and immersed myself in that program so I could better understand the water systems, our water treatment systems and our water distribution systems. And so I feel like I've provided myself a nice rounded knowledge base on the issues of water here locally. Additionally, I've been attending the water board meetings for over a year now. And after having done that, I feel there really is a need for more voices that speak up on the issue of public health and speak up on behalf of the environment. So, you know, I'm taking the information that I learned in the Sustainable Natural Resources program and applying it and using it as a framework. So, and really the idea behind that is in order for us to have sustainability with our natural resources, including water, we need to be giving equal consideration to three sets of values: our environmental values, our social values, which include our health and well-being, and economic values. And so I want to be that voice to make sure that our natural resources, including our water, will continue to be available for our kids, our grandkids, and subsequent generations by using that balanced decision-making approach. So that's really kind of where I'm coming from with my campaign. So in the interest of time, I encourage anyone who wants to learn more about me to visit my website because there's much more information on there. And the website is votekathyearmitage.com. And feel free to reach out to me through social media or email if you want more information, and I'm happy to provide that to you. I also want to say that I encourage you to ask lots of questions today. I may not be able to answer all the questions that are directed at me, but I will commit to getting an answer for you and getting back to you with that information if I need to do a little more research on that. So I just want to put that out in front. So enough about me. I would like to now introduce our wonderful guest speaker, Dr. Karen McLaughlin. So Dr. McLaughlin received her Bachelor of Science in Geosciences from Penn State University and her PhD in Geological and Environmental Sciences from Stanford University. In March of 2007, she joined the Southern California Coastal Waters Research Project, which is a public research and development agency that develops and applies science to improve the management of aquatic systems in Southern California and beyond. Dr. McLaughlin is currently a senior scientist and a regional monitoring coordinator there, and her area of expertise is tracking sources of contaminants and studying how chemical elements are transferred between living systems and the environment, like our water. Her current research includes the use of monitoring programs to see how human-made conditions are affecting ecosystems in the ocean and developing ways to measure water and sediment quality in Southern California. Dr. McLaughlin's research also includes studying acidification and oxygen depletion in our oceans and understanding how our ecosystems respond to various nutrients added by humans into our air and water. The list of journal articles, book chapters, and technical reports authored by Dr. McLaughlin is very lengthy and very impressive. I would encourage you, do you have a LinkedIn account, Dr. McLaughlin?
I do, yeah.
You do? Okay, so look her up on LinkedIn because it will take you a lot of time to go through all of that, but I was very impressed by the very lengthy list. So one of the things I'm trying to address with my candidacy, and hopefully as a member of the board of directors on the Water Agency, is sharing information in a way that everybody understands, because people have different levels of exposure to technical terms and concepts related to water. So I'm going to ask you to improve my description of your background by challenging you to describe what you do to a group of middle school students, because I try to break it down a little bit, but how would you describe it to a group of middle school students so that we can all understand the very important work that you do?
So my work boils down to, I study how human beings are interacting with the natural environment, for better and for worse.
Mm-hmm. Okay, I like that. Okay, and then I welcome you to add anything as a general greeting before we get started.
I'm just really happy to be here, and I'm excited to see people that are engaged in science coming into positions where they can have meaningful change on our water supply, because I think that there are some serious considerations that need to be taken, and they need to be weighed in that sort of careful, analytical way.
Yeah. All right. Thank you. And I'll just add one more thing before we get started with our conversation specifically on water quality. I'm especially appreciative of Dr. McLaughlin's time today because she is also a candidate running for a seat on the board of the Irvine Ranch Water District. And so I know how busy she must be between her regular work and her campaign work. So thank you.
My pleasure.
Yeah. And so since we're both candidates, I'm going to just do a little plug for how you can support your favorite candidates in their races. Sign up on our email lists, follow us on social media, share your favorite posts with your local friends who can help get our names out. If you have an extra hour or two, you can help write postcards, make phone calls to your fellow community members. And really important is giving a financial contribution to your favorite candidates. Running a good campaign is expensive, and candidates need funds to pay for the resources to do voter outreach. So, everything that you see with a candidate's name out there, that costs the candidate money to produce and get out there. So when you contribute, it helps the candidate reach more voters so that they have a better chance to win. So, and then today you're going to see all kinds of candidates reaching out because today's a big fundraising deadline for all of us. So I don't know about you, Dr. McLaughlin, but I'm going to be on the phone making phone calls afterwards for fundraising today to try to meet my goal for today as well. So there's my little plug on how you can help get your favorite science-focused, community-focused candidates elected, okay? Okay, now I'm going to seg into why we are talking about water quality today. I mean, I've already mentioned a number of times, but I want to say it again, that my great group of students and I, we've been hitting the phones hard, we've been talking to voters, and the number one thing we're hearing is we're not sure our water's safe to drink. And so a lot of people are saying, I'm drinking bottled water, or we're filtering our water because we're not so sure, okay? And that brings up a whole other slew of issues in terms of, plastics and bottled water and all that, and extra costs. So, but then, when you go to and listen to the water board meetings, many of the current water board directors insist that the water is clean and safe, and they say they drink directly from the tap. So there's clearly, to me, a disconnect somewhere. So it seems to me that the best place to start this conversation is by looking at what resources do we have available to us regarding our water quality, and let's look at it and let's understand how to use it. So that's why we're going to be looking at the water quality report today, which is a report that's released and updated each year to show the water quality testing that is done on our drinking water, since it's an available resource to us. So I'm going to start really quickly just to give you a little bit of general background information. so that we understand the big picture of water quality. And I'm just gonna really briefly hit on key regulations that protect our water. So at the federal level, we have the Clean Water Act, which was passed in 1972. And what that did is it made it illegal to dump pollutants into waterways without permits. And it established a permit program to control and monitor discharges that are allowed into the waterways. So this made it so that water that makes its way into our drinking water systems is less polluted, okay? And then another federal level regulation is the Safe Drinking Water Act, which was passed in 1974. And that authorized the Environmental Protection Agency to establish minimum standards to protect our tap water. And it requires all operators and owners of public water systems to comply with these health-related standards. And then third one that I want to mention from the federal level is the Consumer Confidence Report Rule. And this states that community water systems must release an annual water quality report by July 1st of every year. Okay, so let's talk about state now. So the state also has regulations. So here in California, the law that governs the water quality regulation is the Porter-Cologne Water Quality Control Act. And Porter-Cologne, those were two legislators that wrote this legislation, so that's where the name comes from. And so this act protects the quality of all waters for the state for use and enjoyment of people. It is meant to attain the highest reasonable water quality and protect the quality of water from degradation, and it applies to all surface and groundwaters within the state. The second piece of important legislation in California is Title 22 of the California Code of Regulations, and what that's done is it established drinking water standards with maximum contaminant levels. So those are the key pieces. I don't want to go into too much detail on that, but I just want to set it up so that there are regulations that have been put in place to make our drinking water safer, and those are kind of the key ones, okay? So I mentioned the Consumer Confidence Report Rule. So I'm going to go back to that now for a second. And so every year as required by the law, SCV Water releases to its public also now its water quality report, or also known as the Consumer Confidence Report. So the most recent report was released just a few months ago, and that's the 2019 data. And that information is available on the website. So this is something that I've been trying to share with the members of the community as well. And so they used to mail it out with your bill once a year, but I think that the cost of that is just really high. So now what happens is, if you pay attention, I forget what bill it is, but in one of the bills, one of the monthly bills, there's like a little slip at the bottom, and it says, if you would like to have the water quality report or the consumer confidence report mailed to you, please return this slip. And so they will mail it to you if you request it. But it is available online for those people who have access online. So what I'm going to do is I'm going to show you how to find it, and then Dr. McLaughlin and I are going to walk you through how to read it. So I'm going to share my screen. Give me a moment. I'm sorry, it always takes me a moment to transition. Oh, I think Stacy, do you have to give me permission to share my screen? Okay, here we go. Thanks. Okay. All right, so let me move this over. So this is the homepage of Santa Clarita Valley Water Agency's website. So if you come up to, oh gosh, mine's blocking it. I don't know if you can see the top. So if you go to yourscvwater.com, that's the website for SCV Water Agencies. That's the homepage for the website. So when you come to the homepage and you scroll down, right here on the front is the water quality report. So we'll click on that, and then it takes you to a scanned version of the water quality report. So it says 2020 because it was released in 2020, but I believe it's based on 2019 data. Does that sound right to you, Dr. McLaughlin? Yeah, okay, it's based on the previous. So I'm just gonna really quickly scan through, and then we're gonna come back to the different sections. But basically, it just kind of gives a general description at the beginning of our sources of water. This is a nice graphic that tells you kind of about all the infrastructure that it takes to bring our water to our area. And then it talks about the Groundwater Sustainability Agency's work here. And some conservation program information. We're going to talk about PFAS later, but that is an issue in our community. So there is some information about what the PFAS is. Here's a nice graphic that further describes where our water comes from. Here's the staff. And then it goes into information that goes into much more detail here in this table. So I'm just going to scroll forward. This is the table this is kind of the beast that we're going to try to tackle today, okay, with trying to figure out what all of this means and if there's any information in here that we need to be concerned about. So I'm going to scroll back up. So all of this information in these few pages leading up to that kind of describe what we're supposed to be seeing and reading here. So I know I went through that really quickly, and we don't have enough time to kind of go through all of the other areas in a more detailed fashion. So my recommendation would be, hopefully what we talk about today will kind of pique your interest to want to learn more, and then you can go back and read this on your own. And then if you still have questions, you can always reach out to me, or you can reach out to the water agency directly as well to get more information. But hopefully this will at least make the basics clear to you. Okay, so I'm going to stop sharing my screen for a second again, so I can go back to my notes. Okay, sorry, I'm terrible at transitioning. All right. Okay. So now we're going to spend the rest of our time looking at that table that I just showed you in detail so that we can understand what it means, since this is the data that we're really interested in. So, okay, I guess I shouldn't have gone out of that. Let me go back to sharing the table. Well, I don't, you know what, Stacy, do you mind sharing the table in your screen so that way I can still see my notes?
No problem.
Okay, we have somebody in the waiting room. Should I let them in? Are you able to see them?
No, can you make me host again, and then I can take care of that and screen share for you?
Yes. Okay, there you go. Okay, so Dr. McLaughlin, Stacy's going to be controlling what we're looking at, so we'll just have to guide her to if we need her to move around a little bit.
Give me one.
Thank you, everybody, for being patient as we toggle back and forth with the different things to look at.
I'm sorry. And so this is going to be different than the thing that I put into the chat, which is the quality report. Correct?
So no, this, yes, we're putting the putting the water quality report up on the screen, and then you're going to scroll up. So we're going to that table at the second to last page of the water quality report.
There it is.
And so while she's doing that, let me just explain a little bit of history with our water agency. So it used to be that we had 4 separate, thank you, Stacy. It used to be that we had 4 separate water retailers in our area. So we had Valencia Water Company, Santa Clarita Company, Newhall Water, and then LA County Waterworks Division 36. And what's happened over the last few years is that they have all been merged together under one large agency, which is now known as Santa Clarita Valley Water Agency. And so everything is kind of being consolidated under the one big agency now. And so one of the things they're still working on in terms of bringing together under one more efficient system is also the infrastructure, but it still is largely run kind of separately in terms of like the piping and things like that. So one of the things we're going to notice when we look at the water quality report, when we look at the top columns, Stacy, are you able to zoom a little bit so that we can read the top columns? Can everybody, maybe it's just me. Okay, so if you see, thank you. So if you slowly scroll to the side, Stacy, people will notice that there are different, so there's Santa Clarita Valley Agency Import Division, Santa Clarita Valley Water Agency, okay, so there's Santa Clarita Water Division, so keep going. Valencia Water Division, Newhall Water Division, and then Newhall Water Division is divided into subsections. And then lastly, there's LA County Waterworks District 36. So you can see here that the testing is done and listed under those kind of subsections. So I just wanted to explain that because that's where that came from. It's kind of goes along with the history of the separate water agencies that we used to have that are still now being merged under the one. Okay, so that explains that. So now this is where I'm going to start asking Dr. McLaughlin questions so that we can benefit from her scientific background to further explain the rest. So before we dive into the values that we see in this chart, let's just talk about water quality and testing in general. So in a general sense, how is our water tested for safety?
So generally, and I just want to note that this table is a summary table. There is a lot of data that's packaged underneath this, and the full water quality reports are available to the public. So if there's anything you see on here that you are particularly interested in or worried about, you can either, if they're not available on the website, which I imagine they are, you can always request them as a matter of public information.
Okay.
So what you're seeing on here are super high level summary statistics about water quality. And the way that they do this is for different constituents, they have different requirements for how frequently they need to monitor the water source. So for groundwater, you don't have to monitor it very frequently, usually just once a year, maybe once every other year, because it doesn't change much. It's trapped inside of a rock. The rock is actually providing protection for that water that's in the aquifer. Surface waters, those are evaluated much more frequently. Usually for some constituents, it'll be measured maybe even daily, sometimes more like weekly, a lot of times monthly, depending on what the constituent is and how variable that constituent is, and how risky it is for human health. So there is a whole set of guidelines for how water districts must monitor these different sources and the different mixtures. And then what you're seeing on this table is each of these regions on your division map, they have different mixtures of water. Some of the water is imported, some of the water is from local groundwater. There's different groundwater aquifers. So those mixtures are then evaluated before they go out for public consumption. And then for two variables, the copper and the lead, those are measured at houses from the tap because there are issues with your plumbing that could impact the quality of the water related to lead or copper. And that's completely independent of what the water SCV is actually doing or where the water's coming from. That's plumbing related. So there's multiple levels of protection, multiple levels of monitoring that go into how knowing what the water quality is like coming to you as a consumer of water.
Okay, thank you. And then let's talk about how contaminants are categorized. Can you talk about that? I know we have primary standards versus secondary standards, so let's explain that. And then let's talk about how they categorize the types of contaminants. Yeah, I'll just let you take it from there.
Sure. So there's a set of primary contaminants that the State Water Board Division of Drinking Water have said these are the ones that we're most concerned about for drinking water and human health. So you must meet these levels or may not exceed these levels. So when you're looking at this table right now, you're going to see something called the maximum contaminant level. It cannot exceed that. Then there are, so those are the primary ones are anything related to human health. Like, is this water going to make you sick? The secondary standards are related to the aesthetic of the water. How does the water taste? How does it look? How does it smell? And you might notice that these things change over the course of a year. I know they do for me in Irvine because the mixture of the water changes seasonally. So sometimes during the year, my water smells a little bit more chlorinated. Like I smell it when I take a shower, and other times in the year, it doesn't smell as much. Those are not related to human health, although different people may be more or less sensitive to those things. I know my husband hates when the water tastes like chlorine, so we use a Brita filter. Um, and that may be true for your house as well. So there's primary ones that are directly related to whether or not the water is going to make you sick, and then secondary standards that are related to how the water feels and tastes.
Yeah. Okay. And then in terms of categorization of the types of contaminants, do you want to talk about like the 5 class, I don't know if they're like truly the classifications, but like inorganic contaminants, organic contaminants?
Oh, sure.
Turbidity, microbial contaminants, and then the radiological contaminants.
Sure. So there's multiple, like you just said, Kathy just said, there's multiple types of contaminant. They're not contaminants, all of them. They're different. We call them constituents.
Yeah.
So microbial ones, these are potentially pathogenic organisms. They don't measure directly for human pathogens. The way that water quality monitoring is set up right now is around these things we call fecal indicator bacteria, or FIB. Maybe you've seen that. When you go to the beach, sometimes they monitor for the same exact thing, whether or not the water has high levels of these things that are associated with human pathogens. In this case, they're monitoring for total coliform, which is like the class of bacterial organisms that include E. coli. These aren't viruses, they're bacteria. They can live and they can regrow in water systems and surface water environments, even in your lawn. Not all of them make you sick. In fact, most of them don't. But what they're doing is they're using this as a marker for bacterial contamination in general. So if it exceeds a certain threshold for total coliform levels, then they go and drill in deeper. Is there E. coli? And if there is E. coli, what kind of E. coli? Is it something that's going to make people sick? So that's like the primary level. If they pass that one, then the water is probably safe for these microbial contaminants. The next level are these sort of inorganic compounds, the metals and the salts. These are the things that are sort of tested monthly. These are not necessarily toxic contaminants, but they're things that are associated with potentially hazardous materials. They're just kind of easier to measure, and they're kind of a robust measure for general water quality across the board. Then they're monitoring specifically for toxic metals. So this is stuff that will make you sick, like lead and copper. They measure these at the tap because, like I mentioned earlier, that your local plumbing can have an important effect on increasing the amount of lead and copper. So there might be lead and copper in the groundwater supply because of natural variability in the groundwater or minerals dissolving from the aquifer. But old plumbing, particularly plumbing prior to, I think, 1990, maybe 1980. So if your house is an older house, they might have used copper piping or brass piping that may have had lead contamination or may shed copper particles. Most new construction uses PVC, so it's not as big of a problem in newer constructions, but because it's a problem that could be local instead of from the water district, they measure it at the tap. There are organic contaminants, and these are the ones that people are probably most concerned with. These are the industrial compounds like pesticides, herbicides, industrial treatment, pollution, things that come from petroleum extraction. These are things that are typically carcinogenic. They are available in very low quantities that can actually, even those low quantities can have significant health impacts. These are tested regularly as well. Then they use turbidity, which is basically just a measure of how much stuff is floating around in the water. So you measure it by like shining a light through the water, and it tells you, you measure the other side and see how much of that light comes through. It's sort of a general indicator for water quality and the effectiveness of their filtration systems. So all the water is pre-treated before it goes to your tap, and this is sort of a good check on how effective that is. They also measure for, because of the problems associated specifically with your area, they check for perchlorate because there is a plume of perchlorate in your water district. This is an inorganic chemical from rocket propellant. and there was I guess a manufacturing facility in the district that had led to a groundwater plume because things were just not great back before the Clean Water Act. So they measure this, and there's a treatment system, as you noted on the table, that you can look at. Then there are a class of what we call chemicals of or contaminants of emergent concern, or CECs. Maybe you've seen that acronym flying around. These are a class of chemicals that we're just starting to learn that they're in the environment and that we should be worrying about them. So PFAS is one of those. These are those per and polyfluoroalkyl substances, and there's two of them that they're looking at, that PFOA and PFOS. There aren't current regulatory standards for any of the CECs, and there are a bunch of them. PFAS is just one. There are, microplastics that are coming on board. There's a bunch of other contaminants that we hardly even know about. There's like the neonicotinoid herbicides and pesticides that are new and coming out. We're not sure what the health risk is. So while we're waiting for this sort of big environmental epidemiological studies to know what the risk is to humans and the environment, they sort of set these, they're not necessarily regulatory, like they're not going to shut down certain things, but they have notification levels. And for PFAS, it's actually gotten to the point where there is actually like a response level. So if it exceeds a certain value, they'll shut the well off or whatever. So those sort of substances, what's on the table is just sort of PFAS now, but I know that they do measure a number of these contaminants of emerging concern just to get a feel for what's potentially in the water, what they might want to start worrying about. Then there's these like radiological components. This is because the water is stored in rock, and rock has radiation compounds. If you've ever lived in some area that has a basement, you check for radon. This is the same thing with groundwater. As water goes through rocks, it picks up uranium. It could come from human sources, but it's mostly because it's trapped underground. So they look for alpha particles and beta particles, the level of those in the groundwater, and there's a lot of things that they can do to mitigate those in disinfection. And then lastly are these disinfection byproducts. Because the water is often a mixture of surface water and groundwater, and there are some potential for microbial contamination, they treat the water with either ozone or some sort of chlorine or chloroamine. And these are the things that provide that sort of chlorine taste. It makes your water taste like a swimming pool a little bit. They're not necessarily dangerous in low quantities, but you can still taste them. They're not great for you if they're in like a level that's high. That's why there are thresholds for them. But there's going to always be some sort of residual of these things in your groundwater because it has to be treated that way, or you would get sick. So they test for the number of those that they can help monitor the taste and aesthetic of the water. So those are the main categories.
All right, thank you. So Stacy, if you can put that table back up onto share screen for us. Let's look back at the table, and if you could walk us through, maybe pick one of the constituents that you think makes most sense to look at. Walk us through going column by column to tell us what we're looking at and how we should be analyzing the information in the table, please.
Sure.
And then I'm going to ask you, while she's pulling that up, then I'm going to ask you, having looked at the report as a whole, what are we learning from, are there things we need to be concerned about with the primary standards, and are there things that we should know about the secondary standards overall?
Sure. Okay, so let's take these, while we got it zoomed out, let's take these first columns just so that you understand what you're looking at. So the farthest left-hand column is the parameter or the constituent that you're looking at. So they're broken down into those classes of chemicals or types of parameters, like the inorganic, organic, radiological, all those things are broken down separately so you can look at them. I think the actual list of what they have to monitor for is quite a bit longer than what's here. So they're just sort of providing you the high level guys that are indicating broadly what the water quality is, and there's probably a lot more detail if you're interested. But let's look at the different columns here. So this first column is units. So this is how those constituents are measured. And you'll notice that some contaminants have different units than other contaminants. And this is purely for your ability to increase readability of the chart, right? So for example, aluminum it says mg/L. So that's milligrams per liter. Arsenic has that little almost looks like a U, but it's actually a mu from the Latin. So that's micrograms per liter. So there's a factor of 1,000 different between those two values. So the reason they do that is because otherwise the top one would be 1,000 and the other one would be 10. So it just makes it a little bit easier for you to read the less zeros there are in any number. And if you go all the way down to the bottom of the chart, you're going to see some that say ng per liter. Let's see if there's one right there. The PFAS, the two PFAS chemicals, those are measured in nanograms per liter. So that's a factor of 1,000 less than the micrograms per liter. Some of them, like pH, that's a unitless compound. It's a sort of a ratio, so it doesn't have any units. So the units are pH units. If you scroll up a little bit, let's look at some of the other ones. So if you stop here, conductivity, that's measured in microsiemens per centimeter. That's related to the charge of the water, because you're basically measuring how much electrical current is conducted through the water. NTU, that's nephelometric turbidity units, which is like super specialized for turbidity. This is just the transmission of light. The odor threshold, I forget what that acronym is for, but it's basically a receptor for smell, basically. And color is also a unitless measure. And then you scroll up, the radio ones are a little bit different. So the radiological compounds, that's picocuries per liter. This is because they measure it on a scintillation counter, and they're basically measuring the rate of decay of these different particles. So that's just also a specialized, it's basically how many of those particles are hitting a sensor per unit time, or per unit, I guess this is a unit per unit volume. The microbiological ones, this is percent of positive cells. So this is a sort of rapid test where they take the water and they throw it in with a growth medium, and then those coliform bacteria either grow in the medium if there's a lot of them there, or they don't grow, and then they measure how many of the cells in their well plate that are fed this substance actually show positivity, and then they just create the percent of positive tests, which give them a really good idea of how many colonies of these critters are in the water. And I think that was all the different types of units. So just so you understand that the units are related to how things are measured, and things are measured with varying levels of sensitivity based on what we need to know about how much or how high the concentrations are that might actually impact human health. So then scroll all the way back up to the top. Oops, no, yeah, up top of the table. Okay, so that first column, what you're looking at here is the maximum contaminant level. So this is the highest allowable concentration of the contaminant that's allowed. The next column is the public health goal, or the maximum contaminant level goal. So the public health goal is a state list, and the maximum contaminant level goal is EPA, or like US EPA set. So they're often the same. So usually they're just going to show you the public health goal, and when they're not the same, usually California is more stringent because we just have stricter environmental laws in general. So yes. So what they're trying to do is set the maximum contaminant level at that public health goal if they can. If usually there's a mismatch because of the method sensitivity. Some of these things are really hard to measure in super low concentrations. That's just, it's not a fault of the water district. They're following best practices, and the way that they measure these things, there are what we call standard methods. It's a book, it's giant, it's like this thick, and it's a list of all the methods that are allowable for drinking water and surface water evaluations. So it's not like Santa Clara Water District can go off and measure things however they want to. They have to follow very strict protocols for how these constituents are measured. And they also have to meet very strict measurements for the level of detection. But sometimes the level of detection is not achievable through our current means. So that's why you might see a mismatch between either this public health goal and the maximum contaminant level, as well as this fourth column, the DLR, which is the detection limit for reporting, or the minimum reporting level. So that's why you might see mismatch between some of these numbers. It's not necessarily because they're trying to get away with something, it's just that we can't measure things great, not everything great. So when you're looking at this table, you want to pay attention to this maximum contaminant level, because that's where action's going to happen if something is exceeding that limit. The AL just refers to an action limit. So this is regulatory, like if it exceeds this level, then you must take an action. Then there is a response, I think it's called response level. Is that right for that acronym?
I think so.
That's like non-regulatory, because either the contaminant is so new that they don't have a regulatory, or it's more of a guidance for something that's not directly related to health risk, but it's bad enough that you might want to do something about it. So that's why those are in parentheses, because I think some of those come into play in some of the other like secondary thresholds. Okay, so that's what you're looking at. When you're looking at those numbers, you want to pay attention to the first one, because that's the maximum contaminant level. So if you want to make sure that everything in your water supply is not exceeding that limit. You also want to pay attention to the public health goal, because that's where you want to be eventually. It's much more stringent, but in a lot of cases they can't necessarily hit it. Like if you look for arsenic, because we're right there. The maximum contaminant level is 10 micrograms per liter. The public health goal is 0.004, so that's going into nanogram levels, because they just don't want to see arsenic. They shouldn't see arsenic. They're trying to eliminate it. But if you look at the detection level that's achievable is 2. So it's nowhere near that public health goal, but it's definitely good enough to get your maximum contaminant level. So as methodologies improve, and they're constantly improving for what it's worth. So if we're not there yet, we're getting there. And I think from my experience with these labs, they're all certified labs. So they have to undergo a rigorous, what we call quality control and quality assurance practices. And they get tested sort of by the state to make sure that they're meeting those goals. So you can be pretty confident that the numbers that you're seeing here are backed by data that's of high quality. Okay, so now let's take an example of one of these inorganic constituents. Let's look at nitrogen or nitrate. Nitrate is a nutrient. It's generally good to have nitrate in your environment because it helps things grow, like plants use it, we use it, it's part of the natural environment. But too much of it, particularly in young children, has a toxicity effect. So that's why they measure nitrate in drinking water and surface waters, because they're trying to make sure that they're not exceeding that level that might start to cause toxicity, particularly in juvenile people and juvenile animals. So if you scroll across, you can see that you have our maximum, in this case, our MCL, the maximum contaminant level, is the same as our public health goal. And our detection limit for reporting, 0.04, is really good, right? So we would really know when we're doing our measurements that we were nowhere near either the public health goal or the... So then as you scroll across, each column for each of these divisions. So let's look at the Santa Clara Valley Agency Import Division. This is the combined imported groundwater mixture. What they're showing you is both the minimum value that they detected in all of their samples, and this is probably one of those samples that's measured monthly. So for all of 2019, they measured a minimum of 0.05 and a maximum of 0.05. And the typical value, which I'm not sure if they're using the mean concentration for all the samples or the median concentration. It'll be one of those, and the mean and the median median are usually similar. So the mean is just the average, right? Like if you add everything up and then you divide it by the total number of samples, that's the mean. The median is the number, like if you ranked everything from highest to lowest, what's the number that's in the middle? And usually they're pretty similar. So a typical value, because there's no range here, is 0.05. But it's not necessarily true for every mixture. There's variability in all of these contaminants, and that's okay. That's totally natural. But you can see that a lot of times it's below. If you see this like less than DLR, that means, it doesn't mean that it's not there. It just means that they can't detect it. So this is where that DLR matters. So for example, going back to arsenic, remember how I said the public health goal is 0.004. There could be 0.004 micrograms per liter in any one of these, but we wouldn't know because the detection level is only 2. So it's way high, right, compared to that 0.004. So that less than DLR, that just means they don't detect it. So it doesn't mean it's not there, it just means it's not detected. Yeah, so then if you go across, I don't think there's anything that exceeded that MCL for any of these compounds, but there are some variability. So like look particularly here at the Santa Clarita Water Division, the maximum concentration was 7, which is pretty high. So the typical value is 0.4, which is a little bit more standard, but every once in a while those nitrate values get a little bit high. So that might be something that you would want to keep an eye on, but it's not anything that you should be overly worried about because it's still less than the MCL. And I think they were all less than that. Yeah, here it's not detected. There's its 0.7. Keep scrolling over. Yeah, so nothing exceeding the MCL. So we're feeling pretty good for, I think when I was looking at all of the inorganic compounds, there was nothing that I thought was particularly concerning. So now I think what I'd like to do is, so basically you can see that if you go across, there's some variability in your water supply. So what's important to know is which division you live in, so that you can look specifically for the water in your area. Know that there's some variability, and know that you're trying to match the values in your area to that maximum contaminant level. And if it's less than that, you can be fairly assured that your water is safe to drink because it's not hitting any of those public health goals. If you have sensitive people in your house, like people on maybe chemotherapy, maybe people who are otherwise immunocompromised, or sensitive children, if the value in your area is high, but it's still not meeting that maximum contaminant level, that's the only time that I would actually consider using some additional filtration. Otherwise, you should be fine. There's no reason to worry. I didn't see anything on this table that would make me not want to drink this water. There are a couple of things to point out though. So if you want to scroll all the way down to, actually let's roll down slowly here. Here's those disinfection byproducts, the bromine and these haloacetic acids and the different amines. Those are the things that are making your water maybe taste a little bit different. The values for the MCL are pretty high for some of these guys. So you might detect them sensorily, but they're not going to cause any problem to your health. But these are the sorts of things that if you get like an activated carbon filter, like a Brita filter, or if you drink the water out of your fridge and you put a little carbon filter in the fridge, that would take that taste away. Let's see, scrolling down. Yeah, there's no problem with any of those. The lead and copper, there were a couple of places, if you scroll over for lead and copper, these are sites tested if you stop here. So what they do for this guy, they're showing you the 90th percentile of the houses that they test. So for this particular site or water division, they're measuring 50 houses. And what they do to calculate the 90th percentile is they take the concentration at all of those houses and they rank them from the lowest value to the highest value. And then they assign the percentage based on its rank. So what percentage of each of those 50 houses is represented by any one house. And then they take the 90th percentile of that list. So in this case, it's generally about like, what is that, 3 or 4 houses. So what's the highest level at that that they measure at that like 3rd or 4th highest house? That's how you get that 90th percentile. So that's sort of like the worst case scenario for the region. And then they're giving you the number of sites that are above the action level. So this is a site that would fail that water quality criteria, and they should shut that off. So in this case, there was one that failed. I think is that lead? That must be lead. I think lead, copper's on top and lead's on the bottom. Yeah, so there's one site that's failing the lead. So if I was in that house, I'd be worried. So this is where you want to look and see if any of the sites in your area, the 90th percentile is hitting near that action level or that maximum contaminant level. And if you are seeing failing sites, this is not necessarily the water division's issue. This is something that you either need to deal with as a homeowner or as a renter and take it up with your landlord because there's a problem with your plumbing. Usually it's because something's being shed from old plumbing. Like I mentioned, if your house is over a certain age, you could be like, if you have brass plumbing or copper plumbing, you could be leaching out some lead. And I did see that in a couple of, if you keep scrolling over, you can see a couple of sites that do have, like this one here has a couple of sites that failed those action levels for both copper and lead. This is based on 2018 data, so it may be worth doing a test at your own tap to see if it's a problem that you should be thinking about for yourself. Okay, scroll back over. Scroll down to some of these secondary standards because these are some of the ones that you might be interested in just for your own knowledge. These are related to, like I say, taste. Like sulfate is something that sort of tastes a bit eggy, right? Like a little bit like eggs. So if you think your house smells like eggs a little bit, that's where that's coming from. It's not toxic, it's not harmful, but it's not appealing necessarily, unless you really like eggs. The chlorides are the thing that's that pool taste that you get. Like if your water tastes a little bit like a swimming pool, that's just because they're trying to keep the microbes from growing in their drinking water. And the drinking water lines, you definitely don't want to have critters growing in there because that's going to make you sick. And then some of these other things are sort of related to just oxidation products that might come into the water. Like iron is going to turn your water kind of reddish. Doesn't hurt you, but it might give the water a different like look. Scrolling down to these additional tests, these are some of the, like, for example, they have that hexavalent chromium. So this is that that contaminant of Aaron Brockovich infamy, I guess. So there are places in California where there are hexavalent chromium from our military bases because they didn't do a great job capturing wash-offs. So you want to keep track of some of this. It was mostly below detection limit everywhere, so I think it's totally not something to be worried about, but you know, keep an eye on it to make track. And this is where they would put some of those additional like contaminants of emerging concern, like things that you want to be, that they're starting to think about and trying to investigate in the local water supply. So this is where you're seeing those PFAS contaminants coming up. Some of these are that you should keep an eye on for yourself are like calcium, magnesium, and then these measures of hardness and alkalinity, because you're going to see if you look across the board that the pH, so pH of fresh water is 7, but your pH in this zone is higher than 7. That's not bad. That just means the water is slightly alkaline, but it's what's creating that crust on your shower doors. So if you're hard water, like you probably heard hard water before, but it creates that sort of calcium carbonate crust on showers and stuff. It's not bad. It's just something you have to use vinegar for. That's why I'm sure we've all done it. I do it on my own. Use some vinegar and wash it away. I think that's all I really wanted to say. If anybody has questions on that.
So I think the takeaway message from this is looking at this report as a whole. When we analyze the units and the numbers under the primary standards, which again are the standards that if those are high, it affects our health, those look to be okay, right? There doesn't seem to be any glaring concerns to you in terms of those in affecting our health. And then I think I heard you say that some of the secondary standards, which again don't affect our health, but may affect the taste, the look, the smell of our water, some of those are a little high, but they're not going to affect our health because they're high. So that's what I'm getting from, as a whole, the takeaway from reading this report with you. Would you say that's accurate?
Yes, I would.
Okay. Okay. So I know we're coming close to the end of our time here. And so I had some additional questions, but I want to allow time for people to ask questions also. So just really briefly, I know we wanted to close in thinking about future considerations. So looking forward, there is consensus in the scientific community that areas that are dry will continue to get drier, and we will once again experience drought. So what considerations should we be making now about our water to ensure that our water remains safe and plentiful for the health of our communities?
Yeah, that's a great question, and it's one that nobody has a good answer for yet. So I feel like this is going to be one of the critical questions for the Southern California and the West in general is how are we going to get water into the future? Our imported water is going to keep getting more and more restrictive because everybody's trying to pull from the same resource. So particularly the Colorado River, like Las Vegas, everyone upstream still needs water. And if there's less water going to that river, there's going to be less water as it hits us. So I think there's going to be a major rewrite on water rights coming up, just based on our new climate reality. And we're going to have to deal with that. So whether or not we want to invest in solutions like the California Water Fix program, where they're trying to create additional sources of water from Northern California through the Delta, or do we want to try to invest in other local sort of more conservation methods? Do we want to invest in using that sort of complete water recycling? Most of our water districts do some level of water recycling where they take our wastewater and then they use it for irrigation. But those cleaning practices are so good now that you can take our wastewater and you can turn it into drinking water to recharge our groundwater systems. So there are new technologies coming on board that we need to be thinking about. We need to be planning as best we can for this, because this is the crisis of the future.
Mm-hmm. Yeah. Okay. And then final question before I go to Cami to read some of the questions that may have come in through chat. If this conversation has piqued anyone's interest, where would you direct people to learn more about water quality, and what good sources of information would you suggest?
There are a lot of them out there. So if you do a search on like California water, you'll hit a list of things to look at. So you want to look at the state Water Resources Control Board's website. They have the Division of Drinking Water. If it's drinking water specifically you want to look at, or if it's water in general, that State Water Resources Control Board website. It's like california.gov, maybe even watercalifornia.gov. That's a great resource. We have some local resources. So my agency, SQUIRP, the Southern California Coastal Water Research Project, has a lot of information on surface waters. And then your own district websites has a lot of information on things you can do for conservation practices. There's the Orange County Society of Conservation Biology if you're looking for ways of developing water-friendly landscaping. So there's a lot of resources out there, and like feel free to email me if you're looking for specific ones, and I can send you a list.
Okay. So Cami's one of my wonderful students. She's going to help me with questions because I haven't been able, too many things that I'm trying to pay attention to. So Cami, will you tell us if any questions have come in, and if they have, go ahead and put them out.
Yeah, so there were a couple questions. If the person who said the question would like to restate it, because I might not say it as well. So the first one's from Gail, asking if 45 revoked the Clean Water Act, and if it did it also allow companies to dump toxins into our waters?
The Clean Water Act has not been revoked. the current administration has been doing everything it can to weaken it, and weaken any restrictions in the name of better for business. Although, as far as I know, that businesses have never done what they can unless they're regulated against environmental action. So yes, it's true that the Clean Water Act has been steadily weakened. I'm less worried about it as a resident of California because our Port of Cologne Act prevents any company from doing any damage. I would be more worried if I lived in a state that didn't have the same protections.
And another question is, should we be worrying about microplastics in our drinking water right now?
Yes. Yes, I am. I'm worried about microplastics. And mostly because we don't know, right? So I mentioned there's this category of contaminants called contaminants of emerging concerns, and there's two types of contaminants of emerging concerns. There's what we call the known unknowns. So what do we know? We don't know what the extent and magnitude of the problem is, but we know what the constituent is. So microplastics is sort of in that category. But then there's this whole class of category like contaminants that we call the unknown unknowns. These are chemicals we don't even know about. So I feel like, yes, there's a lot of things that I'm worried about. I'm less worried about them from a drinking water perspective because the aquifers, especially like from groundwater. So if you're in an area that gets a lot of groundwater, it's less of a concern because the rock filters the water pretty effectively. And then the way that the drinking water is treated, a lot of those contaminants would be eliminated anyway. So I don't want you to go and think, oh my God, my water is contaminated, I need to drink bottled water. It's not true because the treatment levels are really high. I'm more worried about it from a surface water contamination issue. So like receiving waters, what's it like at the beach? What's it like for lakes and rivers and streams? So yeah, just to be clear, I'm not worried about those sorts of things in drinking water as much as I'm worried about them in environmental waters.
And then from Sandra, many repipes of old homes were done in copper. Is there a potential problem with that?
Newer copper is not as much of an issue. It was like older copper that had sort of lead alloys in it that are the primary problems. So yeah, I have copper plumbing in my own home and I'm not worried about it because it's newer. So it sort of depends on the age of your house.
And as a follow-up to the microplastic question as well, probably more generalized, do you filter your own drinking water?
We only filter with a carbon filter. So we have a carbon filter in our fridge. And we just do that for taste, not because I'm worried about safety. I would caution people against reverse osmosis systems because there are other environmental hazards associated with that. When you have an RO system, it produces a brine, and that brine is toxic. So you're kind of adding to a problem. So if you're not like sensitive to hard water or have like an immunocompromised person in your home, a carbon filter is probably just fine if you wanted to filter at all.
And then why do we see sediment in our water, particularly after it sits for a while?
That's probably coming from your plumbing. So it's something that kind of sloughs off your pipes. Particularly, you probably notice this a lot if you've gone on vacation for a while and then you turn your water on right away. Things kind of deposit in the pipes and then they kind of get washed out all along. It's kind of related to the hardness of the water. You could form precipitates in the water as it sits. It's not something I would be worried about, but it's probably something that you want to just like flush your pipes when you come home from vacation for a few minutes until everything's kind of washed out, anything that was sitting there.
And then the last question right now in the chat is, does a Brita filter, I don't know what the acronym stand for, so I don't know if someone else wants to look in the chat and see. Does a Brita filter PFAS or PFOS?
It's not really known. I don't know actually how well it does. It should take it out because it's activated. So the Brita filter, like your standard brand of carbon filtration, it uses activated charcoal, and that works because what it does is it's got a highly charged surface, which kind of sucks any like constituent from the water, and holds it. So that's why you need to change the filters periodically, because the number of what we want to call parking spots on that carbon decreases as more particles get attached to it. And PFAS is charged enough that it should stick on. I'm just not sure how effective it is, but it's probably effective to deal with the low level concentrations that we have in the water.
And then that was the last question.
Thank you, Cami. So I'm looking at the time. I think we're actually a little over, so I want to be respectful of people's time. So once again, I want to thank Dr. McLaughlin for coming on today and helping us understand more about water quality in general, and also walking us through how to read our water quality report. I know that was super helpful to me. Hopefully it was helpful to everybody else as well. And the next time you take a look at that, you'll feel a little bit more confident in what you are seeing and how you're reading it. So thank you again. And I'm now going to turn it over to Layla to close us up. Go ahead, Layla.
Great. All right. So my job here is to reiterate how you can help these awesome candidates get elected. So we're doing a lot of work right now to get Kathye's name out and get her name recognized so we can elect a community-focused voice on the board of our local water agency. So how you can help. One, you can share her website. She mentioned it. I'm going to mention it again. It's votekathyearmitage.com. You can follow her there. You can share it with your friends, particularly those that live in Kathye's district. Follow her on social media. She's on Instagram, she's on Facebook, and she's also on Twitter. So if you see a favorite post of hers that you like, share it. It's important to get her name out there and, again, recognizable. If you have a place for a yard sign, let us know. We will deliver it to you. We have several bundles of postcards left. We will deliver those to you. I love postcarding. I find it very therapeutic with a glass of wine at night or a cup of coffee in the morning. So give it a try. Phone calls. There's always a number to be dialed, and we will train you, and you can hop on the call and make some great conversation. So I encourage you to do that. But the most important thing you can do is contribute to her campaign. So we can get the resources we need to make sure we reach all the voters we need to reach. And no amount is too small. So to donate, you can visit her website, votekathyearmitage.com, and make a donation there. And lastly, we know, our local elections, they matter. They really matter, and they affect us the most. So thank you for your interest in learning about Kathye as a candidate, learning more about the race for who represents you on the board of directors of our local water board, because their decisions, they affect your water quality, they affect how much we pay, and how our environment is impacted. Dr. McLaughlin, did you want to take a couple minutes and just share how we can support you in your campaign and your website?
Thanks. Yeah, just visit my website if you want more information. There's ways to contribute on there. I won't take up much of your time because I want to make sure that we're supporting Kathye.
And is your URL in the chat if you haven't done that?
Yeah.
Yeah, why don't you add that in the chat so we can make sure we support you too. So thank you, everyone. This was really informative.
Thank you very much, everybody, for coming. Appreciate it. Hope it was helpful. And we will, my husband's cheering from upstairs. We will get this onto YouTube. So if you had friends or neighbors who couldn't join us today, you can share it with them so that they can catch up with this later. So thank you again, everyone. We're going to stop recording now.
Kathye, hold on.
Yes.
How do people find out if they are in your district?
Oh, thank you. So if you go to my website, again, votekathyearmitage.com, there, if you go under About, there's also a selection for the district map. And so if you click on that, it will take you to the map where you can see if you're in Division 3 or not, based on where you live. So thank you for that, Sandra. And then similar for Dr. McLaughlin, do you also have districts that you're running in? How can people find out if they're in your district?
Yeah, same thing. Go to the IRWD's website, or if you go to my website, I have the district on there. I'm District 4.
Okay, very good. Thank you. All right, is that it? Any more last questions before we stop recording? All right, thank you, friends. Thank you so much for a great event. Appreciate you coming.